All right, so we are back with another video in this LangGraph series. So in this video, what I wanted to talk about is self-corrective RAG with LangGraph. Now, so if you are evaluating the output of RAG, generally answer relevancy is one of the criteria through which we kind of measure how relevant the answer that is being generated out of RAG. The relevancy is also kind of dependent on the how the documents are retrieved and how relevant are they given the prompt, right? So one of the problem which we have seen in case of LLM or RAG is the hallucination. Like given any user prompt, LLM can also hallucinate, and also the retrieved documents in the RAG process can also be not relevant to the prompt the user has given, right? Like that problem of hallucination, we can take help of this CRAG approach, which is nothing but corrective RAG. And in this approach, we will use LangGraph to build the design workflow or the flow engineering with the help of LangGraph, right? So this is one of the paper which got published earlier in this year, which talks about corrective retrieval augmented generation. And it also mainly tries to address the issue of the hallucination problem, which is also very dominant in the case of RAG, right? So we will see like how this can be addressed using CRAG. So we will use LangGraph to build a solution for this. So this is the workflow that we will try to build. So just an overview of this LangGraph tutorial. Like the user will come up with certain questions, then that question will be used to retrieve certain documents from the vector DB. And once that documents are retrieved, we will add a LLM based grader. So that grader will kind of tell you like which documents are relevant to the prompt, to the given prompt, and based on that it will have a conditional edge. So if there are any irrelevant documents that are retrieved during the retrieval phase, so it will go to a different path where it will transform the query. So this transformation of the query will nothing but a rewrite of the query. Any documents which are not relevant to the user prompt that has been retrieved, so it will go to this path and it will kind of rewrite the query for the web search, and it will try to retrieve the answer using the web search. Then it will generate the final answer. And if all the documents are kind of relevant to the given prompt, then we will take this part and we will directly go to the generation phase, and we will end this whole execution of this graph. So first of all, we will populate the vector DB. So the example which I am using, so this is the few of the papers that I have used, which are related to either Llama 2 or LLM or some study about LLM. So that I have used as the source data. So what I have also used is this utility function, which is being present in this utils folder, and there you can see like the few helper functions are there, which is like populate vector DB, then also get retriever. So this populate vector DB is nothing but it will call this function load docs, uh, which will use this PyPDF loader, PyPDF directory loader to load the documents from a path, and then it will convert it to LangChain documents. Then we will split the documents using this function by using a token text splitter, and then we will load it to the Chroma DB, and in the end we will persist that vector DB, right? And once we call this get retriever, it will just create a retriever out of this vector DB and return the same, right? So as I mentioned, like I will use this utility tool, which is build RAG. So at first I will create an object out of it. Then at first I will call this populate vector DB. I'm creating a retriever out of it. So once that is done, then I will move to this initialization of the keys. So one of the initialization is like Open API key and also the Tavili API key, which will help us to create a web search tool using Tavili, right? And after that, I'm initializing the LLM. And then what we will do is we will create few steps which through which we will create the retrieval grader, right? So we can see like I have created a pydentic object which will convert this documents which will kind of measure the documents based on the relevancy, and it will return this outputs in the binary form, whether yes or no. If the documents are relevant, then it will return yes, else it will return no, right? And then I am kind of adding that pydantic object to the LLM using this with structured output and passing this class of pydantic object. And then we are creating this structured LLM grader, right? And then I'm creating a prompt. In this prompt, what I have written is like, you are a grader assessing the relevance of retrieved documents to a user question, right? And in the end, it will return a binary answer of yes or no based on the relevancy. And then I'm creating a grade prompt and just creating a chain out of it. Like first we are passing the grade prompt, then the LLM with the structured output. So then we are creating this retrieval grader, right? So now we have the mechanism through which we can like retrieve certain documents, and then we can measure the relevancy of those documents. So at first I am passing these questions. Tell me about Llama 2. So as the documents contains Llama 2 related documents, which you can see, like one of the paper is Llama 2. So what it will do is it will retrieve the documents, and using the page contents, we will call this retrieval grader, and we will pass the question and also the document text, which is nothing but the page content of one of the documents, right? And in the end, you will see like it is returned a binary score of yes. So it will tell you based on the given prompt and the document retrieved, it will tell you that it's a relevant documents that has been retrieved. So the binary grader is equals to yes, right? Now, if I ask a questions like, tell me about Llama 3, right? So neither of these documents talks about Llama 3. So if I do a retrieval and it kind of retrieves this part of the page contained from the vector DB, which is not relevant to the question. So you can see like the binary grader is no, right? So we can straight away see that if you are straight away implementing a RAG and without having a grader, and so this will kind of hallucinate and it will retrieve the page content which is not relevant to the user prompt, right? So once this relevant grader is created, then we can move to the generator part. So in this generator part, it is nothing but a RAG chain which we will create. So given a regular RAG template, like answer the questions based on the following context, where we will pass the context and also the user question. Then I am creating a prompt out of it, and then I'm creating a RAG chain by chaining my prompt LLM and the string output parser. So using this RAG chain, we can test it out by passing certain questions along with the documents that has been retrieved using this previous steps, right? So we can see like this is the question was related to Llama 2 and the corresponding document has been retrieved, right? So as I mentioned during this phase, like once grader is executed, it will check like if there is any irrelevant document present or not. And if there are any irrelevant documents that are present, we will move to this part of the conditional edge where we will rewrite the query, we will transform the query, which will be more optimized for the web search, right? So the next thing which I wanted to talk about is this query rewriter, right? So you can see like we have a system prompt which talks about like you are a question rewriter which converts the input question to a better version that is optimized for web search, right? So you can see like we are trying to rewrite the query which will give us more optimized web search retrieval, right? So once that is done, then we are also passing the question to the prompt, and we are creating a question rewriter chain out of this, right? So once that is done, we are creating a Tabulai web search tool, which I have also talked about in detail in last few videos in this LangGraph playlist. And after that, we can go ahead to the graph creation. So at first, as if you remember, like we talked about state. So this state kind of uh, floats around to different nodes of the graph, and it will kind of act, which will enable the graph to act as a state machine. So here we are kind of creating a graph state where we have few of the parameters of this graph state are like question, the generation, the web search output, and also the document that has been retrieved, right? So we are kind of creating the signature of this graph state using this class. And once that is done, we will create certain helper functions. So once these helper functions are created, then we will convert this helper function as a node to this graph, right? So first of all, like retrieve. So this retrieve will fetch the question from the state, and based on that question, it will do a retrieval from the vector DB using the retriever, and it will return the documents. So as we have seen that this is a like a type dict, so all the output that has being outputted from any node should be in the form of dictionary, right? So we can see like we are passing the documents as a key and also the question as a key along with the corresponding values. Then we have this generate function. So this generate function will take the question and also the documents, and it will, using this RAG chain, it will pass the documents as a context and also the question. Then it will generate the answer, and that will be returned in this dictionary. So we will have this generation along with the question and also the documents that has been retrieved. So then we will create a function which will talk about grade documents. So using this grade documents, what we will do is we will get the question, then the documents, and then what we will do is we will have a filtered docs. So this filtered docs is nothing but a list. So there, what we will do is we will kind of loop through each of the documents. We will check the relevancy of the documents. If the documents are not relevant, we will not append those documents to this filtered docs. And if they are relevant, then we will append those docs to this list, right? And in the starting, we are mentioning that web search is no, because if the documents, all the documents are relevant, then we don't need to do a web search. And if the documents are not relevant, then only we will do the web search, right? So as I mentioned, like we will loop through each of the documents, then we will use this retrieval grader, and then we will call that chain using this dot invoke method, where we will pass the question and also the page content of that document, and then we will get the grade. So using this score, we will kind of use this pydantic parser to get the grade, and we will check if the grade is yes, then we will kind of append those relevant documents to the filtered docs. And if the grade is equals to no, then we will say that the document that has been retrieved is not relevant, and we will make the web search equals to yes, and we will not append those documents to this filtered docs, right? And after that, we are returning this documents, which is nothing but the filtered docs, and along with the question and also the value of the web search, right? So if there is any presence of not relevant documents, then this value would be yes, right? Uh, then we have this transform query, which will just rewrite the query using this question rewriter. And also we have this web search, which will just do a web search based on the questions. And then it will create a LangChain document, and it will append those LangChain documents to this list, and it will return this documents along with the question, right? So here we are kind of see that we are calling this web search tool along with the questions to retrieve the relevant answer using a web search, right? So then what we will do is we will create this edge router. So this edge router will kind of get the state, and based on the state, it will retrieve the question, the web search value, and also the filtered documents, right? And if the web search is equals to true, then it will return transform query, else it will return generate, right? So what does it mean is that whenever the web search value is equals to yes, then it will route the flow to the transform query section, else it will directly move the control to the generate phase, right? So once that is done, we can build the graph. So in this graph, like we are using this functions which we have created earlier, like retriever, grade documents, generate, transform query, and the web search, right? And we are setting the retriever as kind of the entry point, and then we are creating an edge between the retriever to the grade documents, And after that, what we will have is we will add a conditional age. So that conditional age, the starting point of conditional age is the grade documents. So it will take the output of the grade documents and it will see like if the return text from the grade document is transform query or generate. So if the query is transform query, then it will move the control to the transform query node, else it will move the control to the generate node, right? So then we are creating edges between the transform query to the web search node and at last, like from web search to the generate node. And in the end, we will have a node, we will have a edge from the generate to the end. So by doing all this, we are creating this edges, which I have mentioned here, starting from the retrieval. Then we have a conditional edge. And if the conditional, based on the conditional edge, it can take either the corrective path where we will like transform the query, rewrite the query, and then do a web search. Else it will directly move to the generate phase. And but while doing the corrective phase also, in the end, we will move to this generate phase, which will finally generate the answer using LLM, and then it will come to the end node, right? With certain questions. So the questions we have started with, like tell me about like what is llama 2, right? So we know like this is the documents that are present in the vector db has the answer for this question, right? So we can see like if we stream these outputs, we can see like at first it's going to the retriever, then it's checking the relevance of the documents retrieved to the question. So it is telling you that all the documents that has been retrieved are relevant to the question. And then it's once as the documents are relevant, then it's moving to the generate phase and it's finally generating this output from the context that has been retrieved from the vector db, right? So then we are passing this question, which is like, what is llama 3, which we have seen that this is the documents that has been retrieved for this particular question are not relevant. So then we can kind of stream this and we can see like how the flow is kind of working. So at first it's doing the retrieval, then it's checking the relevancy of the documents, and we can see like all the documents that has been retrieved are not relevant to the question. Then it's telling you that the documents are not relevant to the question. So it should go to the transform query. Then it's kind of rewriting the query and it's doing a web search. And after doing the web search, it's retrieving the context from the web search. And then it's kind of generating the final answer using the generate phase. So we can see like it talks about like it has like 15 trillion tokens, which is 7 times larger than the dataset that has been used for llama 2. So it kind of giving you a better answer, and it's also comparing the llama 3 with the llama 2 number of tokens that has been used to train the llama 2. So we can be rest assured that this documents that has been retrieved using web search that are more relevant to the question, and this answer is not hallucinating, and this is kind of generating a very good answer, and which also has a higher value of answer relevancy given the prompt, right? So I hope you got an understanding of how we can use this CRAG, which is nothing but corrective RAG, and we can eliminate the chances of hallucination with this methodology that I have talked about using a grader in this LangGraph flow, right? So with this, I will end this video. I hope you like this one. I will talk to you in the next video. Thank you.